Next presentation, that's all say Kai Lu. Kai? Okay.
Good morning, everyone. My name is Kai. I'm a senior major in finance. Thanks for giving me the opportunity to present this 3-semester-long project in undergraduate research conference. Every summer, Penn behrend hosts a basketball shootout tournament for high school girls teams. Typically, the tournament consists of 13 to 17 teams, different number of teams each year, and usually they play 4 games a day, and some years they play only 1 day, but even if it's a 2-day event, we will only focus on 1 day because the 2 days are independent. And junior varsity teams play in year report, and junction center courts 1, 2, 3 are used for varsity teams. And Coach Ross is currently responsible for the scheduling, and she's doing it manually. So there are so many complications in the process. First complication is the size. There are 13 to 17 teams, and each team plays 4 games. At the minimum, there shouldn't be any clashes. And more importantly, teams from the same conference do not play with each other. For instance, Erie teams do not play with each other. Pittsburgh teams do not play with each other. And in addition, there are some desirable requirements, such as earlier time slots should be filled before later time slots. And there are some special requirements from some teams. For instance, some teams will not leave by 2 p.m., and Pittsburgh teams are not able to arrive at Erie until 10 or 11, so their game should not start at that time. And it is also desirable for them to leave by 5 or 6 p.m. And according to Coach Ross, it is very challenging and frustrating because Erie took her a day or 2 to finish the whole schedule. And once she completes the schedule, some teams just suddenly pull out, and she has to do it all over again, so it creates lots of frustration. At the beginning, I also tried to do it manually, and I just realized it's so difficult. So there's a challenge, there's a problem, but there's also opportunity for us to make the process much more efficient and faster. This motivated our project. Now let me talk a bit more information about the problem. There are different number of teams each year. There are 17 teams for 2010 in this particular case. Here's an example of the original schedule that Coach Ross did. And there are 12 time slots starting from 9 a.m. to 8 p.m. and there are 3 courts. Our primary goal is to develop a computer-based tool that can make the schedule under certain competition rules in a very efficient manner. The competition rules are as follows: how many games each team must play, whether a team is permitted to play with another team, whether there are time limitations for team's first game and latest game, and it is desirable to prevent teams from playing multiple games consecutively or too far apart during a day. The performance criteria can be selected by the decision maker so that we can evaluate different proposed schedules. For example, the total time difference between team's first and last game during a day. Our research method is optimization. Optimization is a mathematical tool in an applied math discipline called operations research, which is a discipline that integrates industry engineering, economics, science, and human factors. In particular, scheduling problems fall under the optimization area, which seeks to determine the set of actions and decisions which will lead to the best performance of a system under given constraints. For example, the pioneer paper by Michael Trick and Demirag-Assistant called Scheduling a Major College Basketball Conference was published in 1997. At that time, the Atlantic Coast Conference had a competition tournament involved 9 universities during a 9-week period. Those universities played home and away games. And they used integer programming method and several other methodologies. It is a very difficult problem to solve in terms of computation because there are a variety of ways teams can be piled up, and satisfying all the constraints requires to check all possible matchings, which is computationally very challenging. That is why specified computer software have been developed. One of the examples is CPLEX by IBM, which is the state of art, and we use it for our research project through an academic license. Before checking, CPLEX is a computer programming language. Before checking that, I spent quite some time with Microsoft Excel solver to be familiar with the problem. This helped me understand how a mathematical tool can be used to do the scheduling and how to use computer software to create the schedule. However, solver can only handle small-scale problems. For example, four teams, 2 costs, and 2 time slots. Highlight cell, the upper left means, for example, Team 4 and Team 2 will play at time slot 1 and cost 1. We have to solve a much larger problem. That is why I spent quite some time to gain some exposure to CSAC. Learning CSAC is like learning a new different language. It has its own model file and data file. We have optimization model, in particular, integer programming formulation. The main structure is as follows. First of all, we have to define the decision variables. For instance, Team I play with Team J at time t in cost c. It will give a result as 1, 0 otherwise. So we use 0 and 1 variables. Our objective function is to minimize the number of games. We also try different objective functions, but the results are quite similar. And then next step, constraints. We have 2 main types of constraints. First is the PS2 error case. The next one is general constraints for the scheduling. As you can see the letter here, 2 teams can only play with each other once. Each team plays a certain number of games. Most teams play 4 games, but according to some special requirements from some teams only play 3 games. And some teams cannot start at a certain time, as I mentioned, Pittsburgh team. They're late from Pittsburgh, they won't be able to arrive until 11 a.m., so they usually start at 12 a.m. Some teams want to leave by a certain time, some teams want to leave like 2 p.m. Earlier time slots must be filled before later time slots, so in terms of utilization of the cost and time slots. And according to Coach Ross, it is important to grab the team to make each team play at least in each round once, so that we can have an evenly spread out schedule. As you can see, 4 different colors means 4 different runs during a day. And there are also several general constraints for the scheduling, like a team cannot play with itself, a team cannot have more than 1 game at the given time slot. At this point, we converted all verbal descriptions into syntax language. We wrote all the constraints in our model file. For example, the first one is to make sure that for each pair of teams, the maximum number of games they will play is 1. So teams can only play with each other once. I'm only showing you part of the model file here because we wrote all the constraints in the way that CSAC can understand. This is the most time-consuming part of the project because there are so many constraints that are not straightforward, and there are so many tricks involved to solve the problem. We kept the data file separate, so this gives us flexibility. For instance, thinking about the 2013 schedule that we are going to make in the future, the only thing we have to do is to change the data file and the model file with the available time slots and team names. It's only going to take 5 or 6 minutes to adjust the file. At this point, we communicated with Coach Ross to obtain the original schedule from 2010 to 2012. Here's the original and proposed schedule. After we verified with Coach, she said our schedule can be used. In addition, we introduced some improvements. Runtime, 10 seconds. 3 back-to-back games in the original schedule, now in our proposed schedule. Max time gap for a team's first game and last game during a day in the original schedule, 10 hours, 9 hours in our schedule. And we utilize the time slot and cost more efficiently. We do not have any open spots at the beginning. 2011 schedule. Here is the proposed schedule. Runtime, 5 seconds. As you can see here, we also introduced some improvements in the 2012 schedule, and it is also an acceptable schedule according to Coach Ross. So, given the success of 2010 to 2012 schedule, now we are looking forward to make the schedule for 2013, which will take place in June. And in conclusion, we developed a computer tool based on optimization methodology, which is practice-oriented and also theoretically sound. It is practical because first of all, because it's fast solution in terms of 5 to 10 seconds runtime and 5 minutes to adjust the model file, and it is efficient because of utilization of the time slots and cost. It is also flexible because it can be customized to different teams' special requirements. This is theoretically sound because of integer programming methodology, and also because it guarantees optimality. And one more thing I want to emphasize is, at this point, our project does not end here. It is a 3-semester project, but at the same time, first of all, we are looking forward to make the new schedule for 2013, and second, we think our tool will be able to help for our athletic department. And third, it might also be helpful for the other departments on our campus and in other schools. So overall, I think it's a very good tool. Now I'm willing to take any questions you may have. And lastly, I want to mention special thanks for Coach Fornari. Thanks for your help during the whole process. And it is also an honor for me to work with you, and it is also an honor for me to have Dr. Demirag as my supervisor. Thank you all.
You're welcome.
Okay, we have 3 minutes for Q&A.
Questions?
Okay, I'll go then. How is your study different from 1997 study that you mentioned at the start?
We use CSAT.
So how is it different from that research?
The difference is that they focus on several different methodologies, but we focus on the integer programming methodology. As you can see, we take the advantage of the 0 and 1 variables to create different constraints because there are so many tricks involved. That's one major difference.
Given all the constraints that you have, do you get multiple solutions?
Yeah, we do have different schedules. That is why we have the performance criteria to evaluate different schedules so that we can get the best schedule, and we verified with Coach Ross several times that the best schedule that we can have is the proposed schedule I showed you.
Do you always get a solution, or are there times when you come up with issues that are non-solvable?
Yes, there are sometimes we may have some flexibility, infeasible solution.
Okay.
So we have to adjust a little bit.
What kind of adjustments you make?
So there is, we do have a one back-to-back game in the 2012 schedule. At first we tried to eliminate that back-to-back game, but it was impossible because it will give us infeasible schedule. But we verified with Coach Ross that that team is willing to play back-to-back games so that they can get out there early.
So there is some human intervention also.
So you've been doing this now for 2 years or so, this
Yes.
model, and you said after 2011 you made some modifications to the model and for
So
12
first
to
of all,
improve
we
it?
focused on 2010 schedule.
In 10, okay.
Then we adjust. It took us like 6 minutes to adjust the model file to create 2011 schedule, and maybe 7 minutes to adjust the model for the 2012 schedule.
Okay. So
So
the model
based on the model from 2010.
Okay. So the model works
Perfect.
well. She's happy with it?
This is very
She can't do all the stuff in her head?
You may ask her.
No, I'm just kidding.
It's complicated, so.
She's been doing it for years and years.
Anybody else? More questions? All right. Thank you, Kai.
Thank you.